It is 60s. The first successful commercial database system, the semi-automated business reservation environment system. That system was introduced by IBM to help American Airlines manage their reservations data. 70s were the decade that shaped the relational database management system as we know it today. Edgar Codd published an important paper to propose the use of a relational database model. 80s. Structured query language became the standard query language. 80s witnessed a major decline in the popularity of network and hierarchical database models. Relational database systems became a commercial success. 90s. The advent of the internet led to exponential growth of the database industry and increased investment in online business. Late 90s witnessed increased use of point-of-sale technology. The online transaction processing and online analytic processing began to come of age. Today, everything is driven by data. Databases are everywhere and are used to enhance our day-to-day life. From personal cloud storage to predicting the weather, many of the services we utilize today are possible due to databases. And with that magnitude growth of data, a loud debate started. SQL databases or NoSql databases is the answer for our today's workload and needs. Here, in this video, I will shed some light on the key concepts for both. Let's get started. In general, a database is a collection of records resides on a storage medium. A database management system is a software package deployed on top of an operating system. It is designed to define, manipulate, retrieve, and manage the database files, regardless of the data source. A database model is a type of data model that determines the logical structure of a database and fundamentally determines in which manner data can be stored, organized, and manipulated. Today, the most used database models is the relational model, known as the SQL databases, and a non-relational model, commonly referred as NoSql databases. SQL here is just an abbreviation for structured query language, which became the standard mean of interaction with the relational databases. The NoSQL actually stands for not only SQL. The relational databases model. This model organizes data into one or more tables. A table consists of columns and rows with a unique key identifying a row or a group of rows. The relationships are a logical connection between different tables established on the basis of the interaction among these tables. Typical relational database workloads are online transaction processing, OLTP, and online analytics processing, OLAP. So, what are the characteristics of online transaction processing? The system responds immediately to user requests. Online transaction processing applications have high throughput and are insert or update intensive in database management. These applications are used concurrently by hundreds or thousands of users. The key goals of OLTP applications are availability, speed, concurrency, and recoverability. An ATM machine for a bank is an example of a commercial transaction processing application. Online analytical processing is an approach to answer multidimensional analytical queries swiftly in computing and is considered to be part of the broader category of business intelligence, which also encompasses relational databases, report writing, and data mining. Typical applications of OLAP include business reporting for sales, marketing, management reporting, business process management, budgeting and forecasting, financial reporting, and similar areas. OLAP consists of three basic analytical operations: consolidation, drill down, and slicing and dicing. Now, let's shift our gear towards non-relational databases. The non-relational databases provide a mechanism for storage and retrieval of data that is modeled in means other than tables relations used in relational databases. Non-relational databases are increasingly used in big data and real-time web applications. They are also sometimes referred to as not only SQL, to emphasize that they may support SQL-like query languages or sit alongside SQL databases in hybrid deployment architectures. Motivations for this approach include simplicity of design, simpler horizontal scaling to clusters of machines. The data structures used by NoSQL databases, for example key value, wide column, graph, or document, are different from those used by default in relational databases, making some operations faster in NoSQL. The particular suitability of a given NoSQL database depends on the problem it must solve. Sometimes The data structure used by NoSql databases are also viewed as more flexible than relational database tables. Let's look at key value pair data structure. The key value part refers to the fact that the database stores data as a collection of key value pairs. This is a simple method of storing data, and it's known to scale well. A key value is also commonly referred to as a dictionary or hash, so don't get confused if you hear this term. The key should be unique identifier that allows you to access the value associated with that key. The value in a key value store can be anything such as text, long or short, a number, markup code such as HTML or even Python code, an image, etc. The value could also be a list or even another key value pair encapsulated in an object. White column. Column store databases use a concept called a key space. A key space is similar to a schema in the relational model. The key space contains all the column families. Column family contain all the rows. Now moving to the graph model. In general, a graph uses a graphical model to represent and store the data. It has no predefined schemas, but rather any schema is simply a reflection of the data that has been entered. Some of the graph database management systems support SQL language alongside other languages, as really in some cases SQL is not sufficient. Just also to mention in this regard, some standardization efforts have occurred, leading to multi-vendor query languages like Gremlin, Sparkle, and Cypher. In addition to having query language interfaces, some graph databases are accessed through application programming interfaces. In graph databases, we have nodes, edges, and properties. Nodes represent entities or instances such as person, business, accounts. Edges are the lines that connect nodes to other nodes, representing the relationship between them. An edge always has a start node, end node, type, and direction. Properties are the specific relevant information to the nodes. Lastly, a document-oriented database or document store designed for storing, retrieving, and managing document-oriented information, also known as semi-structured data. The central concept of a document-oriented database is the notion of a document. While each document-oriented database implementation differs on the details of this definition, in general, they all assume documents encapsulate and encode data or information in some standard format or encoding. Encodings in use include XML, YAML, JSON, and BASIN, as well as binary forms like PDF and Microsoft Office documents. In conclusion, the heated discussion around SQL versus NoSQL databases is just a comparison between relational and non-relational databases. NoSQL databases shouldn't be really considered as a replacement for the traditional database, but rather an alternative, another tool under your belt to be used whenever needed. Thanks for watching the video. Subscribe and stay tuned for the next videos. See you.